I'm going to turn on recording for those of you online. So the recording has started, and I'm going to go ahead and change presenter to you, Raghu. So you should get a pop-up.
Yes, I got it.
Okay. Okay, and I can see your screen, so that's great.
Okay, so actually we have a demo being done by one of my teammates. So we may need to change the presenter during the presentation so that he can share the terminal and all.
That'll be fine, and you'll be able to do that, or I can do that.
Oh, okay. If I can do it, yeah, I can do it. Yes, I'll do it. Okay, so can we get started?
Yes, it is right on time. Let's get started. So welcome everyone to some demos for the Hummingbird release, and we're starting with Madar, who's brought in RabbitMQ support. So go ahead and take it away, Raghu.
Hi, Bill. Thank you very much for giving us this opportunity. I know that we were submitting our changes at the end, and you and Thomas were kind enough to take in the changes for the Hummingbird release. And I would like to thank Simon, who was actually responding on the long weekend on the review comment incorporation that we did. So apart from me, we also have Manjunath. He actually is the core developer who developed most of this module, along with Vishwesh, who did the code review. So let's get started. So what we are demonstrating here is a RabbitMQ feature that we wanted in ONOS because we had a path computation element which actually is written in C, and we didn't had any interface to integrate external applications to ONOS. Most of the modules or the applications we have are currently running inside the ONOS process space. So that was the motivation behind this change, and we are also planning to contribute few more changes OS, but this is the first step in that direction. So we in the first release we actually have support for these event types. So we have a device event. So this basically, let me explain you the feature how it works. So basically, the RabbitMQ module is a application inside ONOS, and this application can be activated or deactivated at runtime. So this fits into the existing framework of ONOS. And this module actually registers with the event subsystem for different kinds of events that we are interested in. So at the first cut, we thought these 4 event types are what are actually mostly useful for external applications. Nevertheless, we can extend the supported events if we later feel there is need for more events. I see ONOS supports a huge number of events. I think it has support for around 50 event types. So we will add them as and when we need them. So so we have support for device event. This is the event like whenever a device is added or deleted, you get notified along with the port changes. Even if a port inside a device gets attached, detached, it goes down, we get a notification to our RabbitMQ module inside ONOS, which in turn relays that message to the RabbitMQ server. And the clients who are registered with RabbitMQ server will get notified. But that part of it is actually outside the scope of ONOS, and the deployments can actually customize their own RabbitMQ listeners in whatever way they need. And similarly, we have link event and topology event and packet event. So packet event is something like whenever you are interested in a packet in that is received at the controller. So these packet messages along with the raw buffer are actually passed on to the listeners. So if at all they want to write any control plane applications, or if they want any deep packet inspection or whatever application they want to write, they can actually do it sitting outside the ONOS process space. And the code is located inside apps directory. We have a subfolder called RabbitMQ, and all the files related to this are inside this. We had two changes outside in the apps pom.xml and the bug file, but those are just adding the dependencies and adding the RabbitMQ module. So we also have a properties file inside for this module, which actually can tell the RabbitMQ module what RabbitMQ server it needs to talk to and what are the credentials and all. So we could actually change the properties file. The location of it is given here, and you can change these properties. These are the default properties that it is initialized with. So if you want to have the demo setup that we are currently showing, we need to configure the RabbitMQ server with these properties. So what we are planning to do is set up a wiki page so that we actually can upload the client code that we have along with the RabbitMQ configuration, so that anyone who wants to use this actually have a starting point where to start with. So now I would like Manjunath to present the demo. I'll make him the presenter.
Thanks, Raghu. Good morning to all. Now I'm going to present the functionality of the RabbitMQ, which was implemented. Basically, I'm trying to demonstrate like adding a switch, adding a port to the switch, and setting the switch to the controller, and accordingly, all these events will be generated while using OS VSTL command. And similarly, these events will be captured by RabbitMQ module, and which will capture the event and process the event and publishes those events to the MQ server. And we have written a consumer application, demo consumer application, which basically listen to the MQ server, and the messages published by the publisher will be consumed by this consumer, and it will display on the console. As this setup, we made it as a demonstration purpose. Yeah, in this one actually I have already built a RabbitMQ module and installed that RabbitMQ and activated the RabbitMQ module on the ONOS console. This one, that is ONOS app RabbitMQ, the name of the module. And now I'm going to show that in the MQ server, there are no any message sitting over here, because I just want to make sure the things are, I'm starting from fresh. You can see there is no messages sitting here.
Manjunath, we can't see your screen. So are you showing the terminal?
Yeah, I'm sharing. Go to the meeting.
I think you wanted to show the web page, right?
Web page. You're not able to see the web page?
No.
One second. This is the RabbitMQ admin UI page, where actually when RabbitMQ module will publish us the message, that will go and sit in this queue. Right now I cleared all the messages, so when I generate an event, those messages will publish from the RabbitMQ module, and which will sit in this particular RabbitMQ queue. I'll go into demonstrate generating a individual particular event type, and I'll show how exactly the RabbitMQ will generate like capture the event from the switch, and it will publish that events to the MQ server. And once the all the messages sitting here, I'll just demonstrate how our consumer application is consuming all the events published on the server will be consumed. So now I'm going to add a switches to demonstrate the event which is captured by ONOS framework, and correspondingly our RabbitMQ module will capture the events.
We are not able to see your terminal again.
Now you can able to see, Raghu.
Yeah, it's visible now. Thank you. OVS-VSCTL. I think there is a typo.
You can see there are no any bridge or bridges are added. Now I'm going to add a bridge. BR0. So bridge is added here. Now I'm setting this bridge to the controller. Okay. So this bridge is added, and the bridge is added, and bridge is connected to the controller, which is running on the local system. And we can just see.
Yeah, we can see the device events here.
Yeah. Now I'll add a port to this existing bridge.
Manjunath, can you show the client where we are printing the traces for the device event? I think you showed the controller GUI, right? Logs. MQ consumer, can you show that?
Yeah. Actually, MQ consumer, I have not started the code. Let me publish the events, then I'll run the MQ consumer.
Okay.
Right now, I am not running the consumers because I want to generate events and publish those messages to the MQ server. That's I'm trying to do now.
So this is like you're storing the messages in the MQ server for some time, right? You
just
have
demonstrate that, yeah, you're right.
Oh, yeah.
Can you able to see my screen, Raghu?
Yes.
Now I am adding a port to the bridge. This is the bridge is added here. You can see the message is captured over here. So, for example, I added a device. First, the device added event has been recognized and the message has been published, and it's sitting in MQ server. Similarly, I added
where are you showing it? Is it on the MQ server? Because we are just seeing the terminal.
Okay.
Now, Manjunath, if you select on your control panel to show your entire desktop, then you won't have to keep switching back and forth.
Yes. And each time, if I want to go to different yeah, now you can see the MQ server UI, right? Admin UI.
Yes.
Okay. The events has been captured by RabbitMQ module, and those events are published in the MQ server. Now, right now, these messages are sitting here. Okay. So now I'll run my consumer application, which basically consumes the application events which are sitting on the MQ server. Let me share that screen. This is my consumer application, which is basically run as a standalone Java program. I'm executing this particular jar file, and which is basically having a consumer code which captures the messages from the RabbitMQ server, which are configured with the right server details, which are same as the publisher, as Raghu already explained, that RabbitMQ property file. You can see these all the events which are sitting on the MQ server has been consumed by our application. For example, device added and these things, all the events which are generated while adding a switch and adding a port. And actually, when you see after consuming, there should not be any message sitting in the RabbitMQ server. Just to demonstrate, I'll just to go to that page. You can see the queue is empty now because all the messages which are generated from RabbitMQ model, which are published to the MQ server, are now consumed by our demo consumer application. You can see there is no any messages sitting over here now. Now I'm going to add one more. Now I'm going to add one more switch, and I want to demonstrate the packet events and topology events. So when two switches are connected, in that case we can also show the link added events also. So
So we have two logical ports created here, V-ETH pair. So it's just that we are showing connectivity between these two. Whatever is sent on ETH0 is V-ETH0 is received on V-ETH1. So it'll actually create a link between them, a directly connected link.
now you see after link established, we can see the packet events over here between those two switches.
Yeah, these are the LLDP packets and BDDP packets.
BDDP packets.
And
Okay.
can you show the link event? We have only 2 more minutes, so we need to speed up.
Yes. So I'll show the link events. I think link events is already captured the link added event. I will just show the link removed event. You can see now I removed the device availability, like removed one switch. So that corresponding link has been removed here, and corresponding topology also got changed because the one switch has been removed. Similarly, I will remove other switch from this one, and we can see again topology change because the another switch also removed from the topology. So currently our RabbitMQ supporting these events, topology, link, and packet and device, as Raghu already explained.
Okay, thank you, Manjunath. So can you make me the presenter? I just have 2 more slides and do it. So if any one of you have any doubts in using this module or facing any issues, please send us an email on the ONOS mailing list. Myself and Manjunath follow it up, and we will we'll make sure we'll resolve the issues you're facing.
Guys, just a question. It's always Luca from ON.Lab. Do you have any example of set of applications that you want to enable with this technology already, with this application?
Oh yes, exactly. So that was the idea behind developing this application. We have a path computation element which actually is written in C. So we currently had no way of integrating that with ONOS. So all this work is going towards that. And if you see, that's what was my next slide. So like we wanted to have support for Adara path computation element, which actually is being used in CORD and CORD 2.0. So we are proposing Adara PCE is the main path computation element inside the CORD ecosystem. So for that, we actually needed this support of RabbitMQ. And yeah, we could have various use cases like any external app sitting outside. RabbitMQ has rich publish and subscribe features which we can leverage on. We can also store and replay the events for debugging purposes. So
Right.
Does that answer your question?
Yeah, sure. Thank you.
You're welcome. So I'll just take 30 more seconds. So the next proposed enhancement that Adara is planning to contribute on OS are enhancing the intent framework to provide a richer set of APIs to support SLAs. So Adara actually supports performance-based SLA, which are actually monitored at real time. And we also work on multi-layer integration. So we wanted to have optical extensions in the southbound drivers contributed so that our PCE can leverage all these features in ONOS. So this is a sample JSON format. We were seeing the messages on the command prompt. I just put this for informational purpose. As I told you, we will create a wiki and it will have all these details. And thank you. That's all I had to share.
Wow. Okay, that's really excellent. Thank you for doing the demonstration, and thank you for the contributions. They're greatly appreciated, and some clearly very important use cases. And it really, I think, opens up the world quite a bit for more use cases. So thanks a lot for the participation, and thanks for keeping us on track. Okay, so
I have one question, Bill, if you don't mind.
sure, quick one.
Sure. This is Brian from ON.Lab, and you can answer this quickly, or we can take it offline. But just wondering, did you evaluate any other RPC mechanisms like Thrift or gRPC? And if so, why did you choose RabbitMQ?
So we didn't explore the other one, but we definitely explored Kafka, and our PCE is actually needs reliable message communication. So we read, and our research indicates that Kafka actually we may lose some events, but it performs better. But we don't see so much of message traffic in this particular use case. So we opted for RabbitMQ because it provides us the reliability. So that was the main consideration, so that we'll not have any issues in the network if we miss any event. We don't want to miss any event that doesn't come to the PCE. So
Okay.
that was the reason behind choosing RabbitMQ. But however, the framework is flexible. So if we have a better message queuing mechanism, we should be able to integrate that.
Okay, cool, thanks.
Thank you.
Okay.
This is Madan from ON.Lab. Hey, Bill, sorry, one quick question.
Hey, we've got 2 more presenters, and we have to leave this room promptly at 9 o'clock. So
That's good. I'll take it offline.
And yeah, for respect of the other demonstrators, I'd like to move forward. So, Gaurav, are you ready?
Uh, yeah, hi, Ben. Thank you. Is my screen visible there?
So I can hear you, but volume of the mic is quite high.
Okay.
Try it again.
Okay. Is it fine now?
Much better.
Okay. So, okay. Hello, everyone. Myself, Gaurav Agrawal, and me and my colleague Vinod will be taking up this demo. So basically, we have divided this demo in two pieces for simplicity. Hello. Yeah, so we have divided this demo in two pieces for simplicity. The first piece is like the Yang work for SBI, what we are doing. And the second thing is the Yang work for NBI, what we are doing. So we will be demonstrating it in two pieces. So before moving on to the demo, a quick overview of the Yang work, what we have done so far in ONOS. So as a part of H release, we have continued the work on ONOS Yang tool, which we have started earlier in the GoldenEye release. So as a part of H release, we have enhanced the ONOS Yang tools, wherein the tools has been enhanced to support the advanced Yang constructs like augment, refref, identity ref, etc. Also, the tool has been enhanced to support the auto generation of the Java code for the devices. The SBI, basically the driver and the provider can also use it now. And thirdly, it has been enhanced to add some of the metadata information which is required by our Yang management system to do the automated codec. So these three things has been done for the ONOS Yang tools. So any driver, provider, or application can model their external interfaces. It can be NB, northbound or southbound interfaces in Yang, and can use the ONOS Yang tools to auto-generate the Java code corresponding to it. Also, at the same time, it generates some metadata information. This metadata information is something which is for use of the Yang management system. So I think this ONOS Yang tool we have discussed earlier also, so I'll not go in details of it. The details are already available in the Yang utils wiki. Another thing which has been added as a part of Hummingbird release, we are actually in a process of developing this. So that is like that is something Yang management system. Yang management system is going to be the core of Yang in ONOS. The purpose of Yang management system is to automate the codec functionality which is required by the drivers or application or by providers. And this YMS uses the Yang tool generated Java classes objects for communication with the drivers and application. So basically, if we look at the YMS app, it sits in the application layer, and it provides encode decode functionalities for the driver. So basically, drivers and the provider use this YMS as a utility. So YMS provide a encode method which accepts input as the Yang tool generated Java class objects, and the output of that encode method is the data format string. So as of now, we are supporting XML and JSON in H release. So the objects can be encoded into the XML or JSON, and it also provides a decode function wherein the input is the XML or the JSON string, and the output is the Yang tool generated Java class objects. So this is how it is used in SBI. In case of NBI, YMS is used as a broker. So any external communication apps used to send can send to YMS, and YMS can use the RESTCON for any X protocol to communicate it with the outside world. Same way the return communication also happens. The details of the same is also available in our ONOS wiki now, which can be referred. Okay, so I will be taking up the demo for the SBI, and my colleague Vinod later will take up it for NBI. So let me start for the SBI piece. Okay, just a quick overview of what I am going to demonstrate. The objective of this demo is to demonstrate the auto generation of the Java code corresponding to the Yang using the ONOS Yang tools. And to show the automation of the codecs, that is the encode and decode functions using YMS. So we have added a Huawei driver which uses YMS to do the encoding and decoding to and from the protocol data format. So the test steps goes like this. We receives a JSON flow for this demo. We have taken a flow rule which can be given as an input to a flow subsystem from where it comes to the Huawei driver. And this Huawei driver functionality is it takes the flow rule and it converts the flow rule to the policy based routes. Basically, the Huawei routers, which is sitting at the below, understands PBR. PBR is nothing but a combination of ACL, classifier, behavior. So this driver converts the flow rule to the corresponding PBR. So that is a job of this. And basically driver has modeled its PBR in terms of ACL, classifier, behavior in Yang, and has used Yang tools to auto generate those classes. So basically when the flows comes to the Huawei driver, it uses the generated classes, create an object of those classes, and then it sends to the YMS app for encoding. YMS app then returns the XML string back. The Huawei driver then uses netconf to communicate with the to configure it into the devices. In the same fashion, there is a get operation wherein the Huawei driver encode the get request into an XML string using YMS app, send it to the device, receives a response, then use YMS app for the decoding purpose. So this is something which I am going to demonstrate further. Okay, so before moving on to the demo, let us look at some of the key setup steps which has been done. The first thing is the driver has been added, which is implementing the flow rule programmable so that it can be called by the flow subsystems. The second thing is the demo topology has been prepared. It comprises of 2 routers, 2 hosts. The demo is to send a packet from host A to host B, for which the flow rule has to be added in router 1 and router 2 in terms of PBR. So I will show this first. So basically this is a Huawei driver which has been added, and it is implementing the flow rule programmable. And we have a demo topology over here wherein we have 2 routers and the 2 hosts. Okay, as a pre-step 3, the driver uses the Yang tool to generate the Java code corresponding to the Yang files. So for that, the driver has to add the Maven ONOS Yang Maven plugin into its form file with the configuration parameter generate Java file for SBI, because it is for driver, so this configuration parameter is required. The same build plugin can also be used for NBI without this parameter. And then it needs to place the Yang files in source main Yang and just run the Maven clean install to auto generate the Java files. So let us look into this first. So this is a driver. As of now, we will remove the generated sources. The Java code is generated in target by default. We will build this. So meanwhile it is building. Okay, these 2 are the Yang files which corresponds to PBR of Huawei. So we have written these 2 Yang files and corresponding to these Yang files, the Java code has been generated. This is a Java code basically. More details, maybe Yang utils wiki can be referred for how the generation happens. Okay, moving on to step 4. We have written the ACL classifier and behavior policy generators, which takes input as a flow rule, and it constructs the Java object. To construct the Java object, the Yang tools generated classes offers a builder pattern which can be used directly to generate those objects. And as a pre-step 5, the driver needs to get the Yang codec handler, add its device schemas to the YMS, and once it has added its device schema to YMS, it can then call the encode decode functionalities of YMS. So let me show you this piece. So say for example, like this is a ACL generator, which takes the flow rule as an input and generate an object of ACL. So these are the builder pattern which is auto generated using Yang tools. Using this, the object is constructed, and we call the encode functionality, wherein the input is the object which we have created, the expected encoded format. So for this example, we have taken it as XML, and what type of operation request it is. So the output of this will be the XML string. Also, we need to get the Yang codec handler and add the device schema. So these are the prerequisite for this setup. Okay, now moving on to the demo. Let me first activate the applications. I have pre-created the package and I have kept it. Just waiting for it to be. Okay, so basically I am activating the YMS application netconf Huawei driver and the BGP. Basically we are using BGP to find the next hop IP which is required in the Huawei behavior. After this, I use a postman to post a BGP peer configuration. We can see in the devices that display BGP peer has been established now. Then I use a curl command. Basically, this is to post the network configuration wherein we wanted to add the two devices as a netconf device. So now we can see that the devices are added as a netconf device. So these two are the devices which has been added as a netconf device, and the driver is Huawei. We can see the netconf session in devices also. So netconf session is also established. Now we can see that the ping is not happening as of now because the flow rule is not there in router 1. I have pre-configured it on router 2 as of now. So now from the rest, we will push this flow rule to the device 1. Once the flow rule is pushed, we can see that the ACL has been added, behavior has been added, classifier has been added. So all of this has been added over here, and then the ping is fine. So basically what we have done is like the driver has created the objects of ACL, behavior, classifier, and policy. For these created object, it has used the Yang tool generated classes builder pattern itself, and then have used the encode functionality of the YMS to encode this into the XML string and have sent this XML string down to the devices using netconf. So this is about the encode function. let us see the decode. For the decode, I have written a test CLI. This CLI first it will form a request XML using the encode function. Then once the request XML is sent, we will receive a response, which again YMS will be used to decode that response and get the Java objects.
Right at about a 2-minute warning, Gaurav.
Sorry?
About a 2-minute warning.
Time. Okay. I'll show the decode thing once. Okay. So for the decode, basically we can see over here that we are using the decode function, wherein the input is the XML string and the output is the Java object. So this is all from the SBI perspective. I would like to hand it over to Vinod to show the NBI things now. Just a second, I will how to do that.
We're now eating into iOS time, so please make it quick.
Vinod?
Yeah. Thank you, Gaurav. Is my screen visible?
Yes, it is.
Yes.
Yeah. Okay. So in case of NBI, the applications will model their the interfaces in Yang, and then register use these Yang modeled interfaces to generate the Java classes. Then the managers would implement the services corresponding to the generated Java classes, the Java interfaces, and then register it with Yang management system. So then when any request comes, so the YMS would interact with the northbound protocol. So it is protocol agnostic because there's an abstract communication over here. And right now we are using RESTconf as a sample protocol to demonstrate it. And we translate the protocol agnostic information into Java objects and give it to applications to perform the operation. So as part of, since there is a shortage for time, I will not be going through this because the Yang utils generation is already covered. The basic thing that over here that we need to do is we need to register the services. So here we tell what is the manager which is implementing it, and then what is the service that it is implementing. So once this is registered with us, okay. In our demo, I'll be using a simple topology as an example, which has got list from Yang's point of view. It has got a combination of single instance node and a multi-instance node in a hierarchy. So it would cater to a lot of all the scenarios of data modeling. And in our demo setup, what we have done is we are using a simple Postman as a REST client, and we send a put or a patch request using a Postman. It comes to our RESTCon server, which is implemented by our Canada team, and the RESTCon server translates the REST request into protocol agnostic information and gives it to YMS. YMS interacts with application and then gives a response back to Postman. So okay. Right now, I have enabled for this. We need to activate our YMS application. We have enabled a RESTconf application, and then we have written a test application which is implementing this service, and then we have written a test a CLI to register the application. So currently, all these prerequisites has already been done. So now we can see now this is the the application's URL from where we want to get the data. Currently, there is no data. We can create a node in this application. So we do a post operation to create, and then we can do a get and see that a node is created. Now for this node which is created, we want to merge the termination point or add termination points to this node. So we have sent the request. Then we can query and see that the termination point has been added. So this is a scenario where we can see that in the hierarchy we can incrementally execute. And if you want to execute it one shot, we could create the node with the termination point. Okay, and then we'd be able to see that this is both together that we have created. And then we want to add or merge a particular attribute, so we can still do that. So now basically this gives the complete flexibility of using RESTconf or netconf on the NBI, and protocols, I mean applications can support any protocol which is there in the ONOS, so their applications are not bogged down by what protocol needs to be done. And for example, say we want to delete a node, and we can see that the node 2 has been deleted. So now we have deleted all this. So this is how the working is being shown over here. And now coming to this one, to our manager. So here what happens is the entire concept of subtree filtering, which is really a strong point in netconf, this is also automated. The code is generated in the for applications. Applications do not need to implement this protocol subtree filtering. So they just need to invoke the generated interface, and we will automatically support the applications to do the subtree filtering. So for example, if there's a query in the netconf client to show, give me all the interfaces which are down, so it would just give all that application needs to do is application needs to share its what do you say, data store, and we would be able to pull it out from based on the conditions that is there in the request. So I think because due to lack of time, I think I am not going in deep. If there's any queries, you can definitely send it to us on the mailing list and we'll respond, and it is also there in the wiki page. So I think that's it from us from now. For now, if there's any particular questions, we can take it now or offline. Anything is okay.
Yep, we'll have to take them offline, please. We have a lot. We still have to get through iOS presentation, but thank you very much, Vinod and Gaurav. And this is really the foundation for one of our biggest initiatives in ONOS over the next 6 months. We're doing dynamic configuration, so really appreciate the contributions here. All right.
Thank you, Bill.
Are you ready? Iowa, there we go. Good. It looks like maybe you're still muted, Iowa.
Hello guys, can you hear me?
Yes. Yes, we can hear you.
Yes, I'm sorry, I had some trouble with the audio device. Can you pass the sharing to me?
Yes, I will. Okay, you should have it.
Okay, can you see my screen?
Yes, I can see it now. And by the way, we'll go 5 minutes past the hour. I'm going to lock the door so nobody else can come in the room.
Okay, great, guys. So thanks for the opportunity to do to give us a demo time window. And this time we're gonna do a ONOS ACTN demo for based on H release contribution. So here's a brief review of the ACTN projects. We have the project information on the left side, and on the right side is a is an ACTN architecture. Basically, wanted to show primarily a two-level hierarchical control framework based on the lower level a physical domain network controller, and in the middle a multi-domain service coordinator or the supercontroller. And this is a review of all the pieces prepared for the ACTN contribution in open source in ONOS, and it has deliveries from both southbound and in the application tier, as well as tools like GUI and application that uses the supercontroller function. And here are the list of the contributors with this project. We have a multi-site contribution from both Canada, from the Indian team, from China, and from Korea, all of the people around. And the Hummingbird release for ACTN, the contribution that we have so far are, first of all, about the support for IETF standard Yang model, topology Yang model from both the southbound and northbound. This includes work like implementation for RESTconf client at the southbound and RESTconf server at the northbound. And along with it is a Yang to JSON and to XML encoder and decoder, and also ported IETF topology Yang models to the ONOS repository. And then we have as an application, we have a IETF TE topology NBI app, which feeds to RESTconf server the data store that the external clients can retrieve and manipulate. And also we actually also building a GUI that can show topologies, but at this phase there are still some glitches, which needs to be optimized. So in this demo, we're not going to show a GUI, but rather we will be showing with a external postman to show the JSON string that we retrieved from the northbound. And also we have contributed a topology core application that manages and manages the multiple topologies received from southbound and merge it, and then maintain the topology. So the demo use case is quite straightforward. So we have two domain controller called the PNC for each of the domain, and then for each of the domain we have a simple topology which has two nodes and a link in the domain, and between the two domains we have an inter-domain link. So this is for the two PNCs, and by the way, each of the PNC is also using a ONOS instance, but it runs a RESTconf server from the northbound and expose this topology to the above. And above the two domain controller, we have our NBSC supercontroller running in an ONOS environment in a virtual machine. And from the northbound, then we use an external client, RESTconf client. In our case, we use Postman to query the topologies and from the northbound. And we also have a GUI, like I said, we have a GUI app that actually can talk directly to the topology, T-topology application through the topology API to display the topology in a graphical way. But today we are not going to show that. We're only going to show the left part. So what we will be showing here is the function of T topology retrieval from the domain controllers, and also the function to merge those domain topologies into a aggregated native T topology in the supercontroller in the NDSC. And then we will show this topology from the northbound, and we also will see the relationship between the merged topology and the two domain topologies received from the southbound. So here, what the steps we're gonna see is first thing is we're gonna connect a physical PNC to the NDSC, and then RESTconf client is going to receive the topology from the southbound, and then the RESTconf client will forward the topology T topology as JSON string to a T topology provider in the southbound. And what this T topology provider does is it gets the JSON T topology in JSON, interact with YMS to translate into Yang objects, and then again make the translation from Yang objects into our internal core T topology construct, and then forwarded it through the API provided by the topology application to the T topology app. And next is in the T topology app, it receives the topology and then performs a merging function, which will create a new topology which functions as its native T topology. And then put both the new T topology as well as the two original domain topologies into a topology database. So from the T topology management point of view, now it sees three topologies: one native T topology and two domain topology. And then from the northbound, the RESTconf external RESTconf client will be able to see those topologies through a query. Okay, so here, this is what the picture will show essentially, basically the two T topologies and then an aggregated topology from the top. Okay, so let me get to the demo part. Can you still hear me? Hello?
Yeah, we can hear you, Iowa.
Yeah, okay. I hear silence, so I would just to make sure. Okay, let me switch to the demo window. So as you see here, we have an ONOS supercontroller running in this virtual machine, and on the side, we also have two virtual machines running as domain controller, and they are configured with RESTconf server. In this supercontroller NDSC environment, we have ONOS running, and we have activated 4 apps: the T topology app, which is the T topology management core application, and then the T Yang NBI app, which interfaces with RESTconf server and to provide the data. And then we have a RESTconf server running from the northbound, and also we have a RESTconf client running from the southbound. So what I'm going to do is I'm going to use this Postman to show the retrieve the JSON string received from the topology app. So initially, this MDSC supercontroller is not connected to any domain controller. So if I do a get, which sends the REST-conf string to the server, and what this sees is there's no basically topology in the database. And then what we do next is to connect a domain controller to the supercontroller. And the domain controller is located in this IP address, which is another virtual machine running in the same environment. And we give it a name and then port, RESTconf port. And then once we send it, what's going to happen is the domain controller is going to send its topology through the RESTconf protocol to the supercontroller, and then the supercontroller will receive it and it will then do a merging function, which creates one new topology, which has a exact one-to-one mapping to the domain controller's topology. And as you see from this login window, we get this topology, and we process this event and generated a new topology. So if we now go back and call a get, what you will see is we will have two topologies seen in this output. We have the first, which is the native topology of the supercontroller as a result of the merge, and which has two nodes and actually 3 links, 2 of the unidirectional link between the 2 nodes, and 1 inter-domain links facing the other domain. And also each of the nodes has attributes like the supporting node and supporting termination points and the list of termination points, things like that. So this is the second, the original domain network, and it also, if you see, it has nodes, 2 nodes, and 1 and 3 links, right? 1, 2, and 3. Okay. Now, so far we connected just one domain. Now, if we go to the second domain and connected it to this supercontroller, and you see here the RESTconf string contains an IP address which points to the other virtual machine, the second domain controller, and then we're going to connect this to the supercontroller. And after the connection, then if we do a get again from the northbound, you will see that we have actually now 3 networks, three topologies, right? One, and the first one, which is a merged topology, now it has 4 nodes in total. 1, yeah, and then 2. Yeah. And then it has the other domain, domain 1, both domain 1 and domain 2. Yeah, and then yeah, that's essentially what we see from the northbound. And as you see from the entire workflow, it actually exercises a retrieval from the southbound and all the way going through the southbound providers to the then to the T topology app, and then goes to the northbound and was retrievable from the northbound. So this shows the entire workflow of a T topology retrieve and management function for the ACTN. Okay, so I think that this is pretty much the demo for now. So if you have any questions, just feel free to ask.
So I'm going to ask people to do it offline because we're getting kicked out of here, and I'm going to have a lot of but I really appreciate you doing the demo for us, and also really appreciate the contributions made for ACTN. Yeah. Okay, thank you everyone for attending.